Good day, I'm Reynald Gonyatal and I'm going to discuss transducer and the assigned topic to me is a RTD or resistance temperature detector. So what is RTD? RTD or a resistance temperature detector is basically either a long, small diameter metal wire wound in a coil or an etched grind on a substrate, much like a strain gauge. Platinum is the most common metal used in RTDs. And this is the principle and operation of RTD. A typical electrical circuit design to measure the temperature with RTDs actually measure a change in resistance of RTD, which is then used to calculate a change in temperature. The resistance of RTD increases with the increasing temperature, just as the resistance of a strain gauge increases with the increasing strain. And as you can see on the graph, as the temperature increases, also the resistance increases. The next one is the bridge circuits construction. As you can see in the figure, the bridge circuit, which is consists of three known resistance, R1, R2, and R3, which is R3 is variable and an unknown variable resistor Rx. And then the Rx, it should be RTD, a source of a voltage and a sensitive ammeter. Resistor R1 and R2 are the ratio arms of the bridge. They ratio the two variable resistance for current flow through the ammeter. R3 is the variable resistor known as the standard arm that is adjusted to match the unknown resistor. The sensing ammeter visually displayed the current that is flowing through the bridge circuit. Analysis of the circuit shown that when R3 is adjusted, so the ammeter reads zero current. The resistance of both arms of the bridge circuit is the same. The relationship of the resistance between two arms of the bridge can be expressed as R1 divided by R2 is equals to R2 divided by Rx. Since the value of R1, R2, and R3 are known values, the only unknown is Rx. The value of Rx can be calculated for the bridge during an ammeter zero current condition. And the unknown resistance Rx is given by Rx is equal to R2 multiplied by R3 divided by R1. And here is the other bridge circuit of the RTD. It is called the RTD bridge circuit operation. One of the simple circuit is the quarter bridge Wheatstone bridge circuit, here called two-wire RTD bridge circuit. Our lead represent the resistance of one of the wire called lead wires that run from the bridge to the RTD itself. Lead resistance was of no concern in strain gauge circuit because R lead remained constant at all time. And here is the other one, the three-wire RTD bridge circuit. The three-wire RTD bridge circuit is shown below. It is still quarter bridge circuit since only one of the four bridge resistor has been replaced by the RTD. To analyze the circuit, assume that R1 is equal to R4 and R2 is equal to R3. Initially, when the bridge is balanced. And we're going to recall the general formula for the Wheatstone bridge, that VO is equal to VS multiplied by R3 times R1 minus R4 times R2 and divided by R2 plus R3, R1 plus R4. And it is noticeable that R3 and R2 have opposite sign in the above equation. And here is the other one. By redrawing the equivalent circuit may help explain why the lead resistance cancel out. In the diagram, it is clear that if our lead change equally in leg 2 and leg 3 of the bridge, it is effect cancel out. And I'm going to show a video of demonstration for the application of a RTD. As you can see on the screen, it is shown that the RTD has a long gauge wire. It is made of platinum. And then it is called PT100 RTD. The PT is the platinum, and then 100 is the 100 ohms when the temperature is in 0 degree Celsius. And then the inside is the protection head and then the temperature transmitter inside. And it has a can be output of 4 to 20 milliampere then in a standard analog signal. The 3 pins are used for the transmitter of the sensor. The terminal 1, 2, and 3 is the temperature controller. And here he is going to connect the wire to terminal 1, 2, and 3 for the temperature controller. And then he is going to connect to the digital display to show how the temperature changes. And it said 269 Celsius. And he is going to calibrate the sensor. And then now it is shown that the room temperature is 21.5. And eventually is going to submerge the RTD in a water. And the reading is 47.6. And it is shown that the platinum rod is increasing so that the resistance inside the RTD is also increasing. So the temperature showing is increasing. So that's all for my discussion, and thank you.